If Earth suddenly had rings like Saturn, it would be one of the most dramatic changes in our sky, transforming how our planet looks and how we experience day-to-day life. Currently, our skies are mostly clear of such massive structures, save for occasional passing clouds and the sun and moon. But with a ring system, Earth's appearance from the ground would change dramatically. First, the most immediate visual impact would be the presence of a gigantic, luminous ring encircling the planet. Depending on the size and orientation of these rings, they could span thousands of kilometers across, creating a band of light and shadow across the sky. For instance, if the rings were tilted relative to Earth's equator, they might be visible as a persistent, bright line stretching across the sky during the daytime or as a glowing band at night. The rings could reflect sunlight, making the sky brighter during the day than it is now, especially in regions directly beneath or near the rings. At night, the reflected light could brighten the sky considerably, potentially washing out some of the stars, though not completely obscuring the most luminous ones. The rings would also cause variations in sunlight through a phenomenon called ring shadowing. During different times of the year, the position of the rings relative to the sun would change due to Earth's orbit, possibly creating regions of the planet that experience periodic shading. Much like how an eclipse causes a shadow on Earth, large portions of the planet might be cast in shadow during certain times, affecting the amount of sunlight received. This could impact local climates, leading to seasonal effects even in regions where none previously existed. For example, areas under the shadow of the rings might experience cooler temperatures or reduced sunlight for hours or even days at a stretch. Tides would also be affected in complex ways. Presently, the tides on Earth are primarily driven by the gravitational pull of the moon and, to a lesser extent, the sun. But with rings in place, the additional mass and gravity from the material in the rings could influence tides subtly but measurably. The gravity exerted by the rings themselves might create additional tidal forces, leading to small but significant variations in ocean levels. These variations could occur cyclically as the rings orbit and change their orientation relative to the Earth, likely introducing new tide patterns that could interact with the established lunar tides. The composition of the rings would play a key role in how they influence climate and weather. For example, if the rings consisted mainly of ice particles, they would be highly reflective, bouncing sunlight back into space and potentially having a cooling effect on Earth's climate. Conversely, if the ring material were darker, made up of dust or rocky debris, they would absorb more sunlight, potentially warming the atmosphere slightly or contributing to regional temperature variations. Because the rings would extend into Earth's atmosphere, the particles from the rings could also brighten or dim the sky at different times and locations, affecting visibility and the intensity of daylight. Aside from the scientific implications, such a change would have profound effects on human culture and daily life. Historically, humans have looked to the sky for guidance in navigation, agriculture, religion, and art. The introduction of a prominent ring system would provide a new celestial feature that could influence storytelling, art, and cultural symbolism. Some cultures might interpret the rings as divine or mystical symbols, weaving them into myths and religious beliefs, while others might see the rings as signs or omens. The visual spectacle of these rings would also impact our recreational and aesthetic pursuits. Imagine seeing the rings cast glowing shadows across your yard at sunrise or watching them glow during sunset. They might even become a focus for scientific observation and tourism, with dedicated viewing areas or space exploration efforts aimed at understanding and documenting the rings more closely. The presence of rings could also influence architecture, with buildings or cities designed to take advantage of the shifting shadows or to showcase the rings as a permanent fixture in the sky. Agriculture might also face some changes. Since the rings could modify the amount and quality of sunlight reaching the surface, they could influence plant growth cycles. Regions under the ring's shadow might experience shorter growing seasons or reduced crop yields if sunlight becomes limiting. Conversely, increased reflection of sunlight could boost photosynthesis in some areas. Farmers would need to adapt to these new conditions, possibly altering planting schedules or choosing different crops suited to altered light conditions. From an ecological perspective, the presence of rings could introduce new atmospheric particles, which might affect cloud formation and weather patterns. Dust or ice particles from the rings could serve as nuclei around which water vapor condenses, potentially leading to more cloud cover or even altering precipitation patterns. Over time, this could affect the distribution of rainfall globally, with some regions experiencing wetter conditions while others become drier. In terms of planetary protection and safety, the rings would also present potential hazards. Debris from the rings, small particles or larger chunks, might occasionally drift into Earth's atmosphere, causing shooting stars or meteors. While most would burn up upon entry, larger debris could pose risks to satellites or even aircraft if they intersected the ring debris fields. Additionally, the rings would be vulnerable to space weather phenomena like solar storms, which could disturb their stability. Changes in ring composition or density could lead to increased debris in orbit, raising concerns about space traffic and satellite safety. Finally, the presence of rings could influence Earth's climate on a broader scale through long-term feedback effects. If the rings reflected significant amounts of sunlight away from Earth over extended periods, they might contribute to cooling trends, potentially offsetting some warming caused by human activity. Alternatively, if they absorbed and re-radiated heat, they could add a warming element, amplifying climate change effects. In either case, the rings would fundamentally alter the energy balance of our planet, necessitating new scientific models to understand and predict their influence. In summary, if Earth had rings similar to Saturn's, the effects would be wide-ranging, from visually transforming our sky, influencing tides and climate, to influencing human culture and daily life. The dynamics between the rings and Earth's atmosphere, oceans, and biosphere would create a new environment that would challenge our understanding of planetary science and human adaptation. While the scientific facts make it clear that these changes would be profound, they also highlight how interconnected our planet's systems are and how simply altering one feature, like adding rings, can have cascading effects across the entire planet.